Howdy and welcome to the third and final video on Edexcel's higher tier GCSE Maths sat in June 2022. So this is a calculator paper because paper 2 and paper 3 you can use your calculator for these, so I'm going to use the virtual calculator of mine to show you how to use it appropriately. So without further ado, let's just get straight to the questions. I don't want to waffle on anymore. So question 1, we have a right angled triangle. We know two sides here, the hypotenuse and the other side. We want to find the bottom side. Because it's a right angled triangle and we want to find one side having known the other two, this should scream at you hopefully this is Pythagoras' theorem. So using Pythagoras, what we should know is that one side squared, one of the short sides squared, plus the other short side squared, which is x squared, equals the longest side, the hypotenuse squared. So 4 squared plus x squared equals 8.5 squared. So we can rearrange this. In fact, we could simplify if we wanted. 4 squared is obviously 16. X squared we can leave as x squared. 8.5 squared, if we want to, we can work out 8.5 squared. That gives us an answer of 289 over 4, or 72.25. We can rearrange this now by taking away 16 from both sides to isolate the x squared on its own. And that tells us that x squared must be 72.25 minus 16. So if I just knock 16 off this answer here, that gives me 56.25. That's what x squared is. So what we need to do now is to square root both sides to get x on its own. So therefore, x must be the square root of 56.25. So if I just type in the square root symbol, then the ANS button, it comes out at 15 over 2, which is 7.5. So the answer we need is 7.5 centimetres. So we're off and running. Question 1's finished. Let's now obviously go on to question 2 and get some more marks in the bank. Question 2, t equals 4m squared minus 11. Work out the value of t when m equals minus 3. So we're just going to substitute in the value of minus 3 in place of the symbol m. So just doing it carefully to avoid any silly mistakes. T equals 4, m now is minus 3, all squared, minus 11. Because it's a calculator paper, don't try and do too much on your own. Use the luxury of having your calculator as a legal aid, so why not just use it? So type it in exactly as it looks here. I would strongly recommend putting the minus 3 in brackets. So 4 lots of minus 3 squared minus 11 generates an answer of 25. So when m is minus 3, t must be 25. Part B, make p the subject of a formula, d equals 3p plus 4. That just means our sort of target, if you like, is in the form p equals. So our answer is going to be p equals whatever. We don't know yet. So to get p on its own, the first thing we could do, first decision we could make, would be subtract 4 from both sides, because that leaves us with just 3p on its own on the right. That would give us d minus 4 equals 3p. Then to go from 3p down to just one of them, we need to divide by 3. And if we divide this side by 3, we need to do the same on the other side too. So therefore, p must equal d minus 4, all of that over 3. Now that isn't actually the final answer, because to make p the subject, p needs to be written first. So if we just switch around the order this is written in, putting p first, p equals d minus 4 over 3. This is very important. If you're thinking this is the same as that, normally it is, but if p is a subject, it means p has to be written first. Writing it like this would actually lose you a mark, so be very careful, make sure you write this on your final answer line. Question 3. Rick, Selma and Tony are playing a game with counters. Rick has some counters, Selma's got twice as many counters as Rick, and then Tony apparently has 6 counters less than Selma. In total we've got 54 counters, and the number of counters Rick has to the number Tony has is 1 dot dot p. Work out the value of p. So let's piece together all this information. This is quite a tricky question by question 3 standards. So Rick, I'm just going to call Rick as capital R. So if I say Rick is R, in terms of he has R counters, Selma has twice as many as Rick, 2 times R, double R is therefore 2R, and if Tony has 6 counters less than Selma, then Tony must have 2R minus 6. We're also solely in total they have 54 counters, but because this is a ratio table, I'm very fond of putting it into a table. So we've got Rick, Selma and Tony, R plus 2R plus 2R minus 6. In terms of R, that gives us a total of 5R minus 6. But this 5R minus 6 must actually represent 54 counters in total, because that's what we're told the total actually is. So 54 counters in total means, like I said, 5R minus 6 must represent 54. So we set 5R minus 6 equal to 54, then we can solve for what R must be. So the first step I'd suggest would be to get the 5R on its own by adding 6 to both sides. So that then gives us that 5R equals 60. Then if we divide both sides by 5, then R on its own will be 60 divided by 5, which is 12. So R must equal 12. So then we can plug these in. So if R is 12, then Rick is obviously R counters, which is 12. 2R means 2 times 12, so Selma must have 24 counters. Meanwhile, Tony has 2R, 24 minus 6. 24 minus 6 is 18. And as a double check, if you want to do 12 plus 24 plus 18 does indeed give us 54. But we want the number of counters Rick has as a ratio to the number Tony has. So Rick has 12, and we've worked out that Tony has 18. But we need our answer in the form 1 ... p. So that 12 needs to shrink down to 1. So how do we go from 12 to 1? Well, what we need to do there would be to divide by 12. But to keep the ratio equivalent, we need to do the same to the other bit of it as well. So we need to do 18 divided by 12 too. If you do that on a calculator, which you're more than welcome to do, 18 divided by 12 would give you 1.5. So in simplest form, in the term 1 ... p, the ratio of Rick's to Tony's is 1 to 1.5. Question 4 is a value for money question. So Joe is going to buy 15 rolls of wallpaper. Here's some information in these boxes below about the cost of rolls of wallpaper from each of the 2 shops. So Chic, Decor and Style Papers. Joe wants to buy 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chic, Decor or from Style Papers? So 15 rolls is what's needed. So Chic Decor sells them in packs of 3. So that means we'd surely need to get 5 lots of 3 from Chic Decor. So if we multiply by 5, that gives us 15 rolls, and therefore, obviously, we'd have to do 36 times 5 as well. That tells us that 15 rolls bought from Chic Decor would cost £180. Let's then compare this to if they were bought from Style Papers. So 5 rolls means we'd need 3 lots of 5 to get to the 15 needed. So we need to multiply by 3. So we take the normal price and multiply that by 3 as well, which tells us that the standard normal price would be 70 times 3, which is 210 for 15 rolls. But we need to remember this special offer as well, 12% off the normal price. So the discount here will be 12% of 210. So on a calculator, you could do this in a few ways. 12, shift, get your percentage button, of, we press multiply, 210 for 210. That tells us that the discount must be £25.20, 25.2. So, just writing this up here, that means that the discount, as I said, is £25.20. That needs to come off for 210. So we need to discount that to get the actual total price to be paid with this discount. So 210 take away £25.20 gives us a total of 15 rolls of £184.80. And you can now see this price here is more expensive than what would have been paid at Chic Decor. Therefore, Joe should get these rolls from Chic Decor because £180 is cheaper than £184.80. So something which you might want to write down for your answer might be something like this. Just keep it nice and simple. Joe should buy from Chic Decor. She, or I suppose maybe he'd, save £4.80. So they'd save £4.80 might be safe to put. I don't know. But I'm guessing Joe might be female. Who knows? The main thing is the answer. Question 5, we have a frequency polygon, and we've got the table, and this table's been converted into a frequency polygon, but with 2 mistakes. So Amos has made 2 errors. Look carefully to spot them. They're not immediately obvious, at least not to me, maybe because I'm not very sharp, I don't know. Anyway, so 2 mistakes. The first thing, if I look at the y-axis, it should go up evenly. 0, 10, 20, 30, looks good so far. The next one should be 40, but oh dear, they've put 50. So 50 is the first error. The frequency axis is mislabeled. The 50 should be 40, and I suppose you could say as well that 60 should therefore be 52. So that's the first mistake. The next thing we need to know about frequency polygons is they should be plotted from the midpoints. So halfway in between 0 and 10 is 5. That's correct there. Halfway between 10 and 20 is 15. That's right. Halfway between 20 and 30 should be 25. That one's okay too. As is that one. But this one here isn't right. That should be plotted at 45, but it's been plotted at the endpoint 50. So that's the second error here. So it should be plotted up here instead. So we could say the point 55 should have been plotted at 45, 5. So look, something like this. That point there should have been down 1 square to the left, like so. And so from the point which was correctly plot, this one here, it should have been a straight line down, like so, down to that one. So a slight error, but an error nonetheless. Question 6. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy, presumably one of her friends or rivals, who knows, 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed, give your answer in miles per hour. So step by step, let's just start with the fact she does 15 minutes at a speed of 6 miles per hour. So miles per hour means that many miles in 60 minutes. 6 miles per hour means 6 miles in 60 minutes, because that is how many minutes are in, obviously, an hour. But she's not going for a full 60 minutes, she's going at that speed for only 15 minutes. So to go from 60 minutes to 15 minutes, that's just a quarter of 60. So we need to divide by 4. If she's only running for 15 minutes, she can only go a quarter of the distance she would have run in a full hour. So if we divide both bits by 4, at that rate, she would have done 1.5 miles in 15 minutes. She then changes her speed, though, for the next 40 minutes, and she runs at 9 miles per hour. So presumably she speeds up, she can see that she needs to, get faster to win the race or whatever, I don't know. So 40 minutes at a rate of 9 miles per hour. Well, 9 miles per hour, in the same way as 6 miles per hour means 6 miles in 60 minutes, 9 miles per hour means 9 miles in 60 minutes. But she does this for 40 minutes, not 60. So this needs to be scaled from 60 to 40. The suggestion I'd make would be to divide both sides by 3. That tells us that in 20 minutes, she would have done 3 miles, and then 40 minutes is 2 lots of 20 minutes. So if we double the time, we'd double the distance. So therefore, in 40 minutes, she'd be able to do 6 miles. So 1.5 miles for the first section, and she speeds up and does another 6 miles. In total, therefore, she's covered a distance of 7.5 miles. We're told that Amy takes 45 minutes to run the same total distance that Jessica runs. So we've just worked out that Jessica runs 7.5 miles, so we can deduce, therefore, that Amy must run 7.5 miles in 45 minutes. So let's set this up in terms of a relation between distance and time. So 7.5 miles, but in 45 minutes. Obviously that just means 7.5 miles in 45 minutes. So to work out her speed, giving our answer in miles per hour, we need to get from 45 minutes up to 60. This is 3/4 of an hour, 45 minutes. So how about 1/4 of an hour? If we divide by 3, we'd get the distance she'd cover at this speed in 15 minutes. So dividing both sides by 3, both the distance and the time, that gives us that she must have covered 2.5 miles, 2.5 miles in 15 minutes. So if we now multiply by 4 to get to the full 60 minutes, the full hour, we must therefore realise that she does an average of 10 miles in 60 minutes. In other words, 10 miles per hour, and that is our final answer, 10 miles per hour. Question 7, we've got a diagram showing a rectangle STUV here, TQU, this bit here, T to Q to U, that's a straight line, as is SRV. So it's just saying as well it's a rectangle. The area of trapezium QUVR, which is shaded grey, is A centimetres squared. And we need to show that A, which is the area, is 2x squared plus 20x. There's actually a couple of ways of doing this. I'm just going to show one way, just for simplicity. You could use the formula for the area of trapezium. What I'm going to suggest we do, just to keep it nice and simple, is to split this trapezium up here into a triangle and rectangle. So if we extend a line from R up here, then the height of this line must be the same as the height from S to T. That'll be 4x as well. If from S to R is 3x, but T to Q is only 2x, from Q to this point here must be an extra x, so that 2x plus an extra x has to equal 3x. So we've got the dimensions of this triangle now, and of course we've got the dimensions of this rectangle here, which is 5 long and 4x high. So this trapezium total area is the area of this triangle plus the area of this rectangle. Area QUVR is area of a triangle plus area of rectangle, like I've said. And just label on the dimensions, the area of a triangle is going to be half times 4x times x, because the area of a triangle is half times base times height. And for the rectangle, it's just 5 times 4x. But of course, the area of QUVR is A, so this will tell us A, which is what we're trying to find. So the area is the area of a triangle, like I said, half times base x times the height, 4x, plus the area of this rectangle, which is base of 5, multiplied by a height of 4x. For triangle, half times x times 4x. If we do x times 4x first, that gives us 4x squared. Half of 4x squared is 2x squared, and 5 times 4x gives us 20x. So therefore, we've proven what we need by careful working and reasoning. Working needs to be shown, of course, because it's a show that question, and showing working all the time is a good habit to get into anyway. Therefore, yes, the area is 2x squared plus 20x. Question 8. An electricity company charges the same fixed amount for each unit of electricity used. David uses this graph to work out the total cost of the electricity he has used. For part A, we need to work out the gradient of a straight line. So the gradient, we need to remember, is the change in y divided by the change in x between 2 points on the line. So our first task is to find 2 nice points on the line which we can read with confidence. The first one I'd pick would be 0, 0. The line goes straight through the origin, so I would suggest to pick 0, 0. Now I couldn't really find another nice point really, so I just picked the very end. If you pick a big distance between one point and the other, a bigger thing is easier to measure accurately. So I'm going to pick this point here. You don't need to follow me. You could pick any point you wanted to, as long as it's easily readable. But in my opinion, I'm going at the very beginning and the very end. So what we need to do here is to read off how high this red dot is. So if that's 16 and that's 20, this will be 18. And from 18 to 20, that's a change of 2 units in terms of 5 little squares. So each little square must be 0.4. Be very careful with the scale. So if that's 18, 18.4, 18.8, 19.2, 19.6. So the height of this red one is 19.6. Therefore, the change in y is 19.6 take away nothing, which is just 19.6. And the change in x is 140 minus nothing, which is just 140. So plug that into our calculator. we can just put 19.6, put minus 0 if you really want to, over 140, and that gives 7 over 50, which of course is 0.14. So therefore, we've got 0.14. Part B, we're asked what does the gradient of a line represent? Well, the gradient means every 1 unit along, how far up are we going? So 1 unit along literally means a unit of electricity, and going up is the cost. So it's telling us the cost per 1 unit. So what does a gradient of this line represent? It simply represents the cost per 1 unit of electricity. So putting something like that will give you the mark you need for part B. Question 9a is actually quite rotten. So it's a calculator paper, and it says express this fraction as a power of 10. If you actually type this into your calculator to get an answer, this is a very clever yet slightly nasty question. You'd actually get a maths error. So just to show you what I mean, 10 to the power 360, all divided by 10 to the power 150, multiplied by 10 to the power 90. Looks like you're doing it okay, of course, but if you press equals, your calculator doesn't like it and will probably explode. So this is the examiner forcing you to show your understanding of the laws of powers. So there's no way around it, we need to actually understand what we're doing. So we're going to take this beast here and try and simplify it using our brains rather than calculators. So leave the square root thing alone for now. 10 to the 360 we can leave as it is, and that's all over 10 to the power 150 multiplied by 10 to the 90. We should know using the laws of indices that when the base numbers are the same, these big numbers I mean are the same, and we're multiplying them, we simply add the powers together. So as an overall power of 10, it's going to be 150 plus 90, which is 240. So on the bottom we've got 10 to the power 240. We'll square root it in just a moment. So what we need to do first is to simplify this. So within the square root, we're doing 10 to the power 360 divided by 10 to the power 240. And when we're dividing one power-based beast by another, assuming the bases are the same, they are for both 10s, we simply subtract the second power from the first. We subtract the power we're dividing it by. So 360 minus 240 is 120. It might be useful now to remember that the square root is the same as to the power of a half. So you don't need to show this to the examiner, this is just in a thought bubble here. Just remembering this might well be helpful now. So I'm going to rewrite this as 10 to the power 120, all of which is to the power of a half. And when we have two powers next to each other, a power of a power is sometimes called, we actually multiply these two values together. So 120 multiplied by a half, in other words, a half of 120 is 60, so as a final power of 10, it will actually be 10 to the power of 60. And that's all we need to do for part A, so quite mean, I think, but there you go, sometimes they can be. A nice question, I think. For part B, Liam was asked to express 12 to the power 50 squared as a power of 12. Liam wrote 12 to the power 50 squared equals 12 to the 50 squared equals 12 to the power 2500. Liam's method is wrong. It would seem here that Liam has no respect for logic, and I have no respect for those which have no respect for logic. He's not learnt his logical rules of powers. So Liam's method is wrong. Explain why. So simply put, what Liam should have done, if he had a power of a power, he should have multiplied those powers together. So the correct method would be to multiply the powers. The new power of 12 is 50 multiplied by 2, not 50 to the power of 2. So the correct answer is 12 to the power of 100, not what Liam's put. 12 to the power 2500 is quite clearly way off the mark. Question 10. Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Jane bought it 3 years ago. So for this one, we need to remember that before anything happens to a value, it always starts off as 100% of itself. So at the end of the first year, just thinking of the first year for now, the value of the car decreased by 12.5%. So it started off being 100% of its original value. If we do 100% take away 12.5%, which we can do using the calculator, 100 shift percent minus 12.5 shift percent gives us 7/8. If we press S arrow D, we get 0.875. And this decimal is called the decimal multiplier. It's called the decimal multiplier because it tells us what we need to multiply the original value by to actually make a decrease of 12.5%. So 12.5% off means 87.5% remains, which, as the calculator just showed us, as a decimal multiplier is 0.875. But then for the next 2 years, things change. So the value of the car then decreases by 10% each year for the next 2 years. So if it decreases by 10%, then 10% off means 90% is left, and in the same way as I just showed you, the decimal multiplier for that would be 0.90, which is actually 0.9. I've put it as 0.90 so you can see the relationship between the percentage and the decimal. So piecing this all together, we know what the final value was. We need to know what the initial value was before it went down in value. So what we're going to do here, the end of the 3 years was 17,010. We don't know the start value, so we're going to call that start value simply x. So for the first year, x has been multiplied by 0.875. In other words, that's how you get the decrease of 12.5% in the first year. Then for the second value, this value here from the first year decreases by 10%. So we multiply that by the decimal multiplier of 0.90 for the second year. But it decreases by 10% for the next 2 years, not just one. So we need to multiply by 0.90 again for the third year. And after those 3 years, we're told that its value is £17,010, like so. We can now simplify these three decimals we're multiplying together. So 0.875 times 0.90 times 0.90, we can work out what that is. 0.875 multiplied by 0.9, or 0.90 if you want to, times 0.90, that gives us a value of 0.70875. Don't round this yet because this isn't our final answer and we don't want to incur any rounding errors. So the next step, just simplify that slightly, x multiplied by 0.70875 equals 17,010. This now actually is a very simple equation to solve. We need to have x on its own, we need to get rid of the 0.70875. We do that by dividing both sides of this equation by 0.70875 to isolate x. And if we do that, 17,010 divided by that particular answer, which is stored in our calculator very nicely, we get £24,000 exactly, which is very convenient. So therefore, the initial value x must have been £24,000 when she bought it. Question 11. Raheem has 16 shirts, 5 pairs of jeans, 3 jackets. He chooses an outfit to wear. An outfit is 1 shirt, 1 pair of jeans and a jacket. Work out how many different outfits Raheem can choose. The very quick way of doing this is called the product rule for counting, is we actually just multiply the 16, the 5 and the 3 together. So the quick way of doing it, if you want to skip on to the next question, is 16 multiplied by 5 multiplied by 3, which is 240 different combinations. However, if you want to understand why it's 240, here I go in trying to explain the logic behind it. 16 shirts and 5 pairs of jeans. Imagine before he puts his jacket on how many different combinations he could have. Imagine his 16 shirts lined up in his cupboard or wardrobe and 5 pairs of jeans hanging up on a rack. You might have something that looks a bit like this to choose from. His shirts along the top, shirts and t-shirts, and 5 lots of jeans there. You can see here there's actually 16 by 5, 80 different combinations. Each of these pink rectangles represents a different shirt and jean combination. So here he's got 80 different combinations. But for each one of these 80 combinations he's got 3 jackets to put them with. So let's think of his first jacket. He could have, for example, this nice jacket here, which I'm going to do in a tan colour. You'd have 80 combinations for this jacket. You'd also have another 80 combinations of shirts and jeans to go for his second jacket, and of course the same 80 combinations to go with his third jacket. So in total, 80 plus 80 plus 80 equals 240. The quick way of doing it is 16 times 5 times 3. I've shown you this to hopefully help your understanding, but if you're not sure, try and ask me in class or leave a comment on the video. Question 12, we've got ABC and ACD, which are right-angled triangles. So because these are right-angled triangles, it should be saying to you, it's probably going to be SOHCAHTOA. It's going to be right-angled trigonometry. So we need to work out the length of AB, which I'm going to highlight on in red, like this. But if we look at this triangle here, we only know it's got a 20-degree angle, and that's a right angle. We don't know enough information in this one, so what we're going to need to do is to start off thinking of ADC. But like I said, it's going to involve SOHCAHTOA, so let's get those magic triangles up and ready to go. So, first of all, AC is shared between these two triangles, so it might be a good idea to try to work out AC first. So if I just cover up this one for now and focus on AC. So relative to this triangle we've got here, relative to the 45-degree angle we know, AC is the opposite side. So we want to work out the opposite, so I'm going to highlight O for opposite, and DA is a hypotenuse, so the other one is the adjacent side, which we know is 8. So 8 is the adjacent, so I'm going to highlight A for adjacent. We pick the triangle which we know more information about. We only know one thing here, one thing there, but we know two things in the TOA triangle, so we're going to pick this one. What we want to work out, we cover up. We want to work out the opposite side, so I'm going to cover up the opposite, like so. So the opposite is simply tan of the angle we're talking about times the adjacent. In other words, AC is going to be tan of 45 multiplied by the adjacent, which is 8. So if we do this on our calculators, I'd be amazed if you could do it without, to be fair, it's possible. Tan 45 times 8, in fact, it's actually very easy, I'm not thinking very clearly, that just gives us 8, because tan 45 is obviously 1. Had a bit of a senior moment there, so we can say AC is 8. Now we've got that, we can actually return to the triangle we need to work out, which includes AB. So if I bring back the other triangle on the right hand side now, we should now have enough information to work out AB. Now AB is the hypotenuse of this triangle we've got. This time, in terms of a triangle we want to focus on, in fact because I want to focus on this one, I'm going to cover up the one we just used, so it's less confusing. Relative to the angle we know, which is 20, that 8 side there from A to whatever it was, can't even see, that's actually the opposite side. So we know the opposite, we want to know H. So this time around, we're interested in O and H. So we're going to highlight O and H in each one of these. So I want to know H, so I'm going to highlight H as well. And I do know O. This time, the triangle that has most information is the SOH triangle, so we're going to use this first triangle over here. And again, we need to work out H, so in the same way, we cover up again what you want to work out. Want to calculate H, so cover up H. So H, what's left tells us what to do. H is O over S. So the hypotenuse, AB, is simply the opposite side divided by S. O stands for the opposite side, which is a length of 8, and S stands for sine of the angle we are dealing with, which in this case is 20. So H is going to be 8 over sine 20. So if we work this one out now, press the fraction button, 8 on top, sine 20 on the bottom, press equals, we get 23.390 and so on and so on. The question asks us to give it to 3 significant figures, So the first three non-zero values are 2, 3 and 3. However, next to this 3 is a 9, which forces this third one to round up to a 4. So it's going to be 23.4 as our answer. 23.4 centimetres, I should say, to be exact. Units are important. 23.4 gives us our final answer. Question 13. A and B are vectors such that A is 2 minus 3, and then we're told that 3A minus 2B is 8 minus 17. And our task is to find vector B, well, B as a column vector. So let's just think about this step by step. So first off, we know what A is. A is obviously 2 minus 3, and we don't know what B is, but we are told that 3A minus 2B is 8 minus 17. So A, being a column vector, has a top number and a bottom number. B will be the same. It'll have some top number and bottom number, which we need to find. So we don't know the top or bottom number, so let's just make up some letters to denote what the top and bottom number might be. Then we can work them out. So A is this, B in yellow. So let's call B X on top and Y on the bottom. So just substituting in that B is X and Y, and this letter A is 2 minus 3, we have the following. 3 lots of A, which is 3 lots of 2 minus 3, minus 2 lots of B, which we're calling X on top, Y on the bottom, must equal 8 minus 17. So in brackets, we can actually multiply, like normal brackets, we can expand into the brackets the 3 by timesing by the 2 and the minus 3, and we can also multiply the 2 by the X and the Y in the second one. So 3 times 2 is 6, 3 times minus 3 gives minus 9, and we'll keep the minus on the outside and just double the X and double the Y to arrive at this. So 6 minus 9 minus 2 X's and 2 Y's on the bottom equals 8 and minus 17. So what we need here is to realise that actually we've got 2 equations hidden within. If we just focus on the top numbers, which I'm going to colour code in red, and the bottom numbers, which I'm going to colour code in blue, like so, we can see here that 6 minus 2x's needs to equal 8, and at the bottom, minus 9 minus 2y's gives minus 17. So if we just take out of these brackets and focus on solving these equations, we can work out x and y, and therefore work out what column vector B actually is. So we've got that 6 minus 2x is 8, and minus 9 minus 2y gives minus 17. So we can just solve these equations like we would any normal equations. So here, just solving the red first, in fact I'll just section this out, so I'm not going to cross over. I can add 2x's to both sides. So if I add 2x to both sides of this, what I'd get next is that 6 equals 8 plus 2x. I want to isolate x though, so I can work out what x is on its own. So if I take away 8 from both sides now, on the left I've got 6 take away 8, which is minus 2. On the right I'll just be left with 2x. And finally, to work out what x is, I can just divide through by 2. So therefore, I've got that x must be equal to minus 1. So the top number of this column vector for B is minus 1. In the same way, doing the bottom, for y, I can add 2y to both sides here. So if I add on 2y to the left and the right of this equation, on the left I'll just be left with minus 9. On the right, I'll now have 2y minus 17. I can next undo the subtracting 17 by adding 17 onto both sides. So on the left, minus 9 plus 17, or if you prefer to think of it as 17 minus 9, that gives us 8, and on the right hand side we just have 2y left. Finally, dividing through by 2 on both sides, we should see that y needs to be equal to 4. So then we've worked out what x is and y is, so essentially we've worked out what column vector B is. So what we need to put down is that B must be minus 1 and 4. Question 14, part A gives us a clue in a way. It says factorise fully, not just partially. 4p squared minus 36. So looking at the numbers alone, 4 and 36 are both multiples of 4. So first off, we can factorise out a 4 from both of these terms. to give us that this equals 4, then brackets p squared minus 9. We now need to remember the difference of two squares. P squared is obviously p multiplied by p, and 9 is 3 squared, 3 multiplied by 3. So we can say that in the brackets, that's the same as p plus 3, then another brackets, p minus 3. So the completely factorised answer to this is 4, and the p squared minus 9 becomes p plus 3 and p minus 3. For part B, we've got 3 brackets to expand. The wording here is more complicated than what it needs to be. This is almost the examiner trying to see if you'll get confused, and don't panic because there's nothing to be confused by. To multiply 3 brackets in a row, we'll just multiply 2 brackets first, and then multiply that result by the third and final bracket. My way of doing it is to just take the last 2 and multiply those out first. So let's expand out 2m minus 5, 3m plus 1. You could use a FOIL method if you prefer. My tendency is to use the box method like so, where we put one bracket along the top and the other bracket down the side. And what goes in these boxes is the result of what you multiply by the top when you multiply it by what's to the side. So in this first box, we're going to do 2m multiplied by 3m. So 2 times 3 is 6. M multiplied by m gives us m squared. So the first box will be 6m squared. The second box, 3m multiplied by minus 5, gives us minus 15m. 2m multiplied by 1 for the bottom left is obviously just 2m. And finally in the bottom right box, 1 multiplied by minus 5 gives minus 5. Then simplifying this, we've got 6m squared. 2m's minus 15m is minus 13m, and of course the minus 5. And so these two brackets expanded out would give us 6m squared minus 13m minus 5. The next step then, as I've said, is to take this result and multiply by the bracket m plus 4. So now we know that we can simplify this m plus 4, 2m minus 5, 3m minus 1 as simply m plus 4 multiplied by this, because 6m squared minus 13m minus 5 is the same as this. We can now do this in exactly the same way. Using the box method, along the top we can write 6m squared minus 13 minus 5, and down the side we can write m plus 4. So first box, 6m squared times m is 6m cubed, minus 13m times another m is minus 13m squared, minus 5 times m gives minus 5m, 6m squared times by 4, 6 times 4 is 24, so that gives us 24m squared, minus 13m multiplied by 4 gives minus 52m, and minus 5 multiplied by a positive 4 gives us minus 20. So then, fully simplifying this down, we've got 6m cubed, 24m squareds minus 13m squareds gives us overall 11m squared, because 24 take 13 is 11. The normal m's, minus 52 of them take away another 5 gives minus 57m, and finally minus 20. So our fully simplified solution is 6m cubed plus 11m squared minus 57m minus 20. Question 15 is about circle theorems. So P, Q, R and S are 4 points on a circle. P, X, R and S, X, Q are straight lines. We need to prove that triangle PQX, this top one here, and triangle SRX, this one at the bottom, are similar. So, step by step, let's talk this through. So looking at point X here, we can see it makes an X angle. So I love the name it's been labelled X because I think of this as an X angle. But of course you can't get marks, sadly, for just saying these are equal because it makes an X. We need to remember the technical term for opposite angles, and it's vertically opposite. So if you've got two angles meeting opposite sides of an X shape, these are called vertically opposite angles, and they are always equal. So our first line of reasoning, I'd suggest, would be to say that the angle QXP, this one here, is the same as the angle made as you go from S to X to R, this one at the bottom. They're equal, and you need to put in the reasoning, vertically opposite angles are equal. The next couple are going to be based on circle theorems. So I always think of this shape as a dicky bow, and the corners of the dicky bow have to be equal to make it neat. A very sort of silly way of thinking about it. I'll explain how to think it through using the proper language. So if I imagine a chord going from P to S, this is going to be angles in the same segment theorem. So we can think of PS as being the base of two triangles that are both standing on the base PS. So first of all, we've got triangle PQS, which has got the same base PS as this triangle PRS. And so because these two triangles are standing on PS, the angle at the circumference, Q, and this angle here, R, must be the same. But the fancy terminology we need to use is this. We need to be saying that Q and R are the same because these are angles in the same segment. So in other words, we've got one segment here, and the major segment is here, so Q and R are the same. This angle Q is formed as we go from P to Q to X, or you could say P to Q to S, or PQX rather. And this angle at R is made as we go from S to R to X. Or you could have said from S to R back to P, it makes the same angle. And the important word we need to include is the circle theorem rule, which is angles in the same segment are equal. There's now also the same theorem again, but looking at it from the chord Q to R. So looking at Q to R, we forget about this in a moment, and think about this chord here, there are also two triangles stood on QR. So the first one is triangle QPR, and the second one is triangle QSR. And exactly the same reasoning as we saw before, because P and S are in the same segment over here, not this tiny, tiny one, and they're both touching the circumference. Angle QPX has to be the same as angle RSX. So that yellow one is the same as that yellow one by the same circle theorem, because angles in the same segment are equal. QPX equals RSX. So to show that two triangles are similar, all we need to show is either A, one is an enlargement of the other, but we're not told any sides, so we can't go via that route. The second way that two triangles have to be similar is if all the angles in the triangles are the same. And that's what we've proven. Triangle PQX has this yellow, green and blue angle, and triangle SXR, or SRX as it's called here, has the same three angles. So we just need to conclude by mentioning that fact. So finally we could say something like PXR and SRX are similar because they're similar because all the angles in them are equal. So we need to conclude by returning to the question, and that's all we need to do for question 15. Question 16, we have this formula for P. So P is a square root of 2e all over f. E is 6.8, it says, correct to one decimal place. So what this means is that before e was rounded, it must have been between two values we need to find. But if it's been rounded nearer to 6.8, then it must be closer to 6.8 than to 6.7 on the other side and 6.9 on the high side. So if you imagine a number line like so, then e obviously is closer to this one than 6.7 or 6.9. So the absolute cutoff between it being closer to 6.7 and 6.8 would be this halfway point here, which is 6.75, and likewise between 6.8 and 6.9, the absolute cutoff would have been here at 6.85. So in other words, before the number was rounded to 6.8, it must have been in between 6.75, but definitely no more than 6.85. If it were 6.85, technically it would have rounded up to 6.9, but putting 6.85 is just easier than writing 6.84999 recurring. So therefore the error interval for E is 6.75, E 6.85. In the same way, we need to calculate the error interval for F, and F has been rounded off to 0.05, correct to one significant figure. So imagining a number line for F, which has been rounded to 0.05, then clearly it must have been closer to 0.05 than to 0.04 on the lower side, or 0.06 on the higher side. So in the same way as before, the absolute boundaries must be halfway between 0.04 and 0.05 here, but absolutely no more and not allowed to be 0.055, which is this one here. So these are the boundaries, and like I said, the lower bound must be 0.045, and the absolute limit must be 0.055. And again, if you're thinking, yeah, but if it was 0.055, it would have rounded up to 0.06. Technically, you're right, but putting this, we're saying this is what it's not allowed to be. This is the absolute limit. This is what it is allowed to be. So the error interval for f is 0.045, f 0.055. So using these error intervals, we're actually asked to work out an upper bound for the value of p. Upper bound means the absolute maximum p could be. So to make p the maximum possible value, we need to make the top of this fraction as big as possible. In other words, we're going to pick the maximum possible e, whereas to make the fraction as big as possible, we also need to make the bottom of this fraction as small as possible. So we're going to pick f is 0.045. Again, just to say my same point, if you're thinking, well, can I pick e to be 6.85? Well, yes and no, we can actually, because writing 6.8 for and an infinite number of 9s for 9 recurring would literally take you more than your whole life. So we're allowed to just call it 6.85. So like I'm saying, this is our formula for working out the maximum possible p. We're going to pick Emax, which is 6.85, and the absolute lower limit for f, which is 0.045. So now we can just substitute in these values into this formula, which now becomes this. Now at this stage we need to get our calculators out and actually perform the calculation. So all we need to do is to type in first off the square root symbol, and this is a fraction, so I'd suggest we type the fraction button in and press 2 times 6.85 all over 0.045. Press equals, and we get this strange expression here, but not to worry. We need our answer to, what does it say, 3 significant figures. So if we press the S arrow D button, we get 17.44 and other numbers. So to 3 significant figures, 1, 7 and 4. Does that 4 round up? No, because it's next to a 4, which is lower than 5. So our answer is just simply 17.4, and that's all we need to do for this one. So equals 17.4, and I'm going to underline in red because that's become my new habit. Question 17. We have a table giving information about the distances in miles that some Year 10 students live from school. And what we need to do is to draw a histogram for this information. So histograms, we should be thinking almost automatically of a formula for them. So the formula for histograms, which I'm talking about, is that frequency density equals frequency divided by class width. Fat Dad's feast on chicken wings is my silly way of remembering the order this formula goes in. So we're told the distances, so we've got these class widths. So for example, this class width here is 1, this one's 0.5 and so on. And we're told the frequencies, so from these we can calculate the class widths, and I'm going to suggest we make an extra column to do so. Sorry, I mean frequency densities, what am I talking about? And to work out frequency density, we cover up FD for frequency density, and that tells us that to calculate frequency densities, we take the frequency and divide by the corresponding class width. So this first one, frequency is 90, class width from 0 to 1.0 is exactly 1, so 90 divided by 1 gives us 90. The next one, 48 divided by 0.5 would give 96. 22 divided by 0.5 is 44. The next one has a width of 1, so 8 divided by 1 is just 8. And the final one, 12 divided by 2, because 5 take 3 is 2, 12 divided by 2 gives 6. Now they've not given us here an actual scale for the graph, so we need to think of our scale ourselves. So the absolute maximum we need is 96. So it might be tempting to think of this as 10, 20, 30, 40, 50, then it wouldn't actually all fit on. So what I'm going to suggest is each 5 squares is 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ultimately, it's not a huge issue as long as your scale is consistent and works and is easily legible. But I think the most obvious one is each 5 squares is worth 10 on the frequency density scale. I need to label on that as well. You can't just imply it yourself. Tell the examiner by labeling on your scale something like this. I've put 60 in an arrow because the frequency density label there was in the way of where I wanted to type 60, and I was too lazy to just scribble this off. So hey ho, there you go. So now we just add in the bars. So the first bar goes from 0 to 1 and needs to be 90 high. So we need to draw this on first. So that's the first bar. The second bar goes from 1 to 1.5 and is 96 high. So that's an extra 3 squares higher than the first one, according to my scale anyway. The third bar, the fourth bar is much lower, and the final bar is even lower still and quite wide. So that's what it should look like, that characteristic shape. Part B, again, is a histogram, this time showing distances in miles that some Year 11 students live from school. Now, this time, we're told that the number of Year 11 students that live between 1 and 2 miles from school is n. So between 1 and 2 miles from school. That's going to be this bar here, which I'm going to just highlight in a second. But we need to recall that the area of each bar represents the frequency of it. So this one here, the area, I'm thinking of it in terms of squares. You could think of it in terms of literally length and width if you wanted. But it's 15 squares high, 15 little squares I mean, and 10 little squares across. So the area is comprised of 150 little squares. So those 150 squares are representing a frequency of n. So to put it even simpler, I can think of it as being 150 is equal to n. But we want to find an expression related to n for the number of Year 11 students who live between 3 and 5 miles from school. Now between 3 and 5 miles from school is this end bar here. So if I highlight this in green and consider the area of that as well in terms of little squares, you can see it's 3 squares high and the total width is 20 squares. So if it's 20 by 3, that's a total of 60 little squares. So 60 squares is equal to what exactly in terms of n? Well, we've got our answer here essentially. We just need to scale down from 150 to 60. There's a few ways of doing it. You could divide by 150, then times by 60, but I'm going to suggest, just because you can, of dividing by 5. If I divide by 5, 150 divided by 5 gives me 30, and 1n divided by 5 gives me 0.2n. So 30 squares is worth 0.2n, or 1/5 of whatever n is. Now, to go from 30 to 60 squares, we can simply double both sides of this. So if we times both bits by 2, 60 squares, which is the actual area of this bar representing what we need to find, is 0.4n. Therefore, our answer is, in terms of n, 0.4n. Question 18, in my opinion, might be the hardest one of the whole paper. So I'm going to try and unpick it with you step by step by step. We've got a prism, A, B, C, D, S, P, Q, R. Okay, so the prism is just the whole 3D shape, and this is the very fancy way of writing down the prism. So the base A, B, C, D of a prism is a square of side 14 centimeters. So let's start with this. I'm going to highlight the base to make it even clearer that it is a square, like so, and each side is 14 centimeters. I've not labelled this side yet because the next line tells us we need to split side BC into a certain ratio. So T is a point on BC such that BT to TC is in the ratio of 4 to 3. So we can work out BT and TC as a separate ratio question. When it comes to ratios, I'd suggest we do a ratio table, something like this. So if BT is 4 lots, TC is 3 lots, that's a total of 7 lots. But actually, because it's a square, BT plus TC is actually worth 14 centimeters. So these 7 lots represent 14 centimeters. So therefore, to go from 7 to 14, we need to multiply by 2. Each piece, each share, each lot, however you think of it, must be worth 2 centimeters. So we need to multiply all values by 2. So BT, 4 times 2 is 8 centimeters. TC, 3 times 2 gives us 6 centimeters. So let's label this extra bit of information on now. 8 and 6. Next of all, as if it wasn't enough information already, the cross-section of a prism is in the shape of a trapezium of area 147 centimetres squared. And we're told as well that from C to R, up here, is 12 centimetres. The cross-section is just essentially the shape of a front and the back. So I'm going to label on the back in green, like so. That trapezium has an area of 147. So let's just consider this trapezium first and see if we can work out the length of SD. We're going to need SD because our goal is to find this angle here at T, but we'll come to that in just a moment. So let's see if we can work out SD from D to S, DS or SD, doesn't matter, using the fact that the area of trapezium is 147 cm squared. At this point, we need to also remember the formula for working out the area of a trapezium, which is as follows. It's half A plus B multiplied by H. The way I think of it is it's the average of the two parallel lengths added together, then half to get the average, multiplied by the perpendicular distance between the two parallel edges. So what it is, in this case, is half of whatever SD is plus 12, multiplied by the perpendicular distance between SD and this side, which is 14. So plugging these values into this formula, knowing as well that the area of it needs to be 147, we have this. 147 is half of whatever SD plus 12 is, multiplied by 14. We can now solve this equation for SD in a few different ways. The first decision I'm going to make is to double both sides to get rid of this half. So double 147, that's going to give 294. This half therefore disappears. I'm left with 294 is whatever SD plus 12 is, times 14. The next decision I'm going to suggest we make is to divide both parts by 14. And that then gives us that 21, because 294 divided by 14 is 21, 14 divided by 14 cancels, is SD plus 12. Finally, to work out SD, we can just subtract 12 from both sides. So therefore, SD has to be 21 minus 12, which is 9 centimetres. We can now add this in to our diagram. But there's still more work to be done, believe it or not. So we're done with this trapezium, so I'm going to wave that goodbye for now. And now we're going to focus on something else. If we look at this square base and imagine a line going from D to T, like so, we could actually use Pythagoras, knowing that from D to C is 14 and from C to T is 6, to work out this dotted length dt at the bottom. So just considering this little triangle at the back end of the base of the shape, which I'm going to colour in yellow, I'm just going to put it over here to work on, we should be able to spot this as Pythagoras' theorem. So dt squared, the hypotenuse squared, equals that side squared plus this side squared. Like so. 14 squared plus 6 squared, well, we can do that, I suppose. 14 squared plus 6 squared, that gives us a total of 232. So dt squared is 232. Now we can just square root that answer we've got, and we get that dt therefore must be 15.231, and so on and so on. Bear in mind though, our job isn't to work out dt, it's to calculate an angle, so don't round this off yet too soon. I would suggest to leave it in this awkward form and only round off at the end. So dt, I'm going to label that length on here because we worked it out. So that's what we've got. So that triangle now has served its purpose, so I'm going to just get rid of it now. And now we can focus on what the actual question's asked us. The actual bottom line of the question is to find the size of the angle between the line ST and the base ABCD. So we're wanting to find this angle here, in between this dotted line, that dotted line, and SD. So colour coding it on, we want this blue angle on this weird sort of 3D angled out triangle. I can't even describe what it's meant to be, but this is what we need to picture. The base is 15.2-ish, its height's 9, can we find that angle? So I'm going to just copy this triangle out here so it looks a bit nicer and clearer. And we're trying to find this angle. It's a right angled triangle, of course, because the base is a square and it goes up perpendicularly, so we can use right angled trigonometry, in other words, good old fashioned SOHCAHTOA. Because we got this angle to find, what sides do we know relative to the angle in question? Well, the 9 is the opposite side, so I can colour code in O for opposite. This one's the hypotenuse. We don't know it, we don't need to know it, we don't care. So the other side is always the adjacent, so we do know the adjacent is 15.23. So I can colour code in A for adjacent. Which one of the SOHCAHTOA triangles is most coloured in? Which one do we use, in other words? It's the TOA triangle, because you know both opposite and adjacent. And to find the angle, we're going to use either sin, cos, or tan minus 1, but because we're opting for the tan triangle, we're going to do tan minus 1 of opposite divided by adjacent. So the final calculation after all that legwork is that we need to do tan minus 1 of 9 over 15.23, 11, and so on and so on. So this answer's stored, it's not been rounded, so I'm going to press Shift, tan minus 1, fraction button, 9 over that number, which the calculator stored for me, so I'm just going to press ANS, close brackets, and we get 30.5779, and so on. We need our answer to correct to 1 decimal place, so the 0.5 will have to round up to 0.6, because next to the 5 is a 7. So our final answer has to be, therefore, 30.6 degrees. I think that was a pretty beastly question, personally. If you managed to understand and get that, then very, very well done indeed, and I mean that sincerely. Question 19, we have to show that these fractions, one minus the other minus 1, can be written in the form ax plus b all over x squared minus 4, where a and b are integers. I'm going to just write this down using my pen. So we've got 3x over x plus 2 minus 2x plus 1 over x minus 2 minus an extra 1. So it needs to be written in a fraction. So we need to combine it all under a certain fraction. So if we're doing one fraction take away another, just with numeric fractions, we need to have a common denominator. So my method for doing this, which I tell my classes, each teacher is different, I do cross, cross, and then smiley face. In other words, what I'm meaning by that is we're going to multiply this bit here, both top and bottom, by the opposite denominator, x minus 2. So I'm going to have 3x, x minus 2 on top, all over x plus 2, brackets x minus 2. This one, the same idea, minus sign, so copy that in. I'm going to multiply both top and bottom of this one by the opposite denominator to this one, which is x plus 2. So the numerator here is going to become 2x plus 1, and then x plus 2, all over x minus 2, x plus 2. But for simplicity, I'm going to write that as the same order as the first fraction. Let's look at that minus 1 as well. So what to do with that minus 1? Well, weirdly, the minus 1, just make myself a bit more space here, apologies, minus 1 needs to be combined as well. So if you just think about writing 1 as a fraction, 1 is as a fraction when you have the numerator the same as the denominator. So what I'm going to do here is just write the same common denominator, x plus 2, x minus 2, and on the top I'm going to write exactly the same thing. Almost running out of space. Because that just allows me to combine this as one fraction, which is our target. The top and the bottom are the same. Whatever you do divided by itself, it gives us 1. So that's just a trick, really. So that's a way of writing 1 as a fraction. So next step would be to write all of this over the same common denominator. So 3x brackets x minus 2, we can expand this. So we're going to have 3x times x, which is 3x squared. 3x times minus 2 is minus 6x. Then here, because I'm minusing off, I'm going to be very careful indeed. I'm going to put minus, and for now, I'm going to leave what I get in brackets. 2x multiplied by x gives 2x squared. 2x times 2 is 4x, plus an extra x here when I expand it out gives me 5x's in total. And then 1 times 2 gives 2. Then finally, this one over here, x plus 2 brackets x minus 2, that's actually a difference of 2 squares. So what I'm going to do here is just not expand it out in the slow way, but just use the fact that it's a difference of 2 squares to do it the nice, quick way. I'm getting my fraction line mixed up here. Quite embarrassing. It's going to be x times x, which is x squared, and then 2 times minus 2, which is minus 4. But again, I'm minusing off all of that. It's going to leave it in brackets for now as x squared minus 4. And as well, looking at the denominator, all denominators are common. They're all x plus 2, x minus 2. And because, in fact, I did that with the next step, this is also a difference of 2 squares. So I could have wrote that exactly and quickly as x squared minus 4 as well. As long as you remember to do it, it doesn't matter too much. So next step, let's try and get this neatened up. So x squared terms. So I've got 3x squared here, but I'm taking away 2x squared and I'm minusing off x squared there. So the x squareds will all cancel. Now the x terms. I've got minus 6x minus another 5x's. That in total is minus 11x. Now the digits, the simple units, I've got minus 2 here, then minus 4, so therefore I need to add 4, because a minus next to a minus makes it a plus. So minus 2, let's see how easy it is to make a mistake, almost did it myself, minus 2 plus 4 gives plus 2. And finally, x plus 2, x minus 2, using the difference of 2 squares, I need to put in that's x squared minus 4. Not that we need to say what a and b are, but in our case, a is minus 11 and b is 2. And that's our final answer. So that's question 19 done and dusted. Question 20, we have an iteration formula. So the profit made by a shop increases each year. The profit made by the shop in year n is p subscript n. And given that the profit made by the shop in the next year is p subscript n plus 1, then we have this relationship here. So p subscript n plus 1 equals some number a multiplied by p subscript n plus 800, where a is a constant. It's got this table showing the profit in 2018 and 2019. Work out the profit predicted to be made by the shop in 2021. Now, before I begin explaining how to do it, I just need to try to tell you that this looks always much more complicated than what it is. N plus 1 compared to n just means the next number along. So, for example, if n was 1, n plus 1 is 2. So in our case, for 2019, the profit made in 2019 will be a multiplied by the profit from the year before, which is the profit in 2018, plus 800. So we can start off by using this, using the fact that we're given it for 2018 and 2019. So the profit in 2019 will be the same as a, whatever a is, multiplied by the profit in 2018 plus 800. But because we're given the profits in 2019 and 2018, we can actually just substitute these values in. So 29,600 for profit in 2019 equals a times 24,000 plus 800. We can now solve this equation to work out what this value a is. So my first decision I'm going to make is to take away 800 from both sides. So that would then give me 28,800 equals a times 24,000. Then finally we can divide both sides of that by 24,000. So 28,800 divided by 24,000, that gives us 6 over 5, which is 1.2. So therefore, the value of a, once we divide it by 24,000, is 1.2. So our formula, therefore, is p subscript n plus 1 is 1.2 multiplied by the profit from the year before, plus 800. we need to get to 2021, so we need 2 extra uses of this formula to go from 2019 to 2020, and then from 2020 to 2021. So we need to use the formula twice in 2 steps like I've put on here. So for 2020, it's going to be 1.2 multiplied by the profit in 2019, which we're told in 2019 it's that, plus an extra 800. So just substituting in these values. So for 2020, it's going to be 1.2 times 29,600 plus 800. So using the calculator again to just do this step. So we're going to do 1.2 multiplied by 29,600 plus the extra 800 on top. That gives us 36,320. Just make sure I've remembered that right, 36,320, yep. Now we use this value here, because that's the value in 2020 we just worked out, then substitute that one in to the formula one more time. So therefore the profit in 2021, which is what we're trying to find eventually, is going to be 1.2 multiplied by the profit in the year before, 2020, which we worked out in the previous step, 36,320. Then we're going to add on to that the obligatory 800, because the formula is always plus 800 at the end, no matter what. So one more use of a calculator, and then we're finally done. So because that value of 36,320 is already stored, I can now just do 1.2 multiplied by that answer plus another 800, and that gives me a total of £44,384. The question doesn't say to round off to any particular value, so just leave it as it is, exactly 44,384. And that's all we need to do. Let's now have a look at the next one, question 21. Question 21, Ray has 9 cards numbered 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Roy takes at random 3 of these cards, so he's going to pick 3 cards. He works out the sum of the numbers on the 3 cards and records the result. Sum is just adding the numbers together. So we need to work out the probability that the result of that is an even number. So if you pick 3 numbers and add them together, how could you actually end up with an answer which is even as well? Well, there's actually 4 different ways of doing this. The first scenario is you pick an odd number first, an odd number second, and then an even number. If you're doubting me, just try some actual numbers for examples. So let's say it was 1, 3, and then 4. 1 plus 3 plus 4 is even. So you could have odd first, odd second, even last. Or altering this order slightly, it could be odd first, even in the middle, then an odd finally. Or it could be even first, odd for the second picking, and odd for the final pick. Or the other way of doing it would be if all numbers which are picked are all even. So because it's probability with multiple steps, probably a good idea to do this as a tree diagram. You don't have to, but strongly recommend doing it. So first of all, the first picking could be either, of course, odd or even for the first card. Then the second card has more branches. And then finally for the third card, you've got your final branches looking like this. Lots of branches, but remember, we only need 4 different potential steps here, so we don't need to fill in the probabilities for each and every branch necessarily. This first scenario, what's the probability of picking an odd first of all? Well, we've got 1, 2, 3, 4, 5 cards out of 9 which are odd, so the chance of picking odd first is 5 out of 9. To pick odd for a second time, if odd's picked first, there's 1 fewer odds to choose from, so there's only 4 odds left, now out of a total of 8. So odd for the second picking is 4/8. Then finally to pick an even, there's 1, 2, 3, 4 even cards left, but now because 2 have already been picked, there's only 7 left in total. So the chance of picking an even last is 4/7. To work out the probability of an odd, and then an odd, and then an even, we multiply the probabilities on these branches together. So odd, then even is 5/9 times 4/8 times 4/7. So we've done one step. The second scenario, what about it being odd first, then even, then odd? Well, odd first we worked out as 5/9. If odd was picked first, there's 8 cards left to pick from. No evens have been picked yet, so there's still 4 evens out of 8 to choose from. And then for the odd to be picked last, 5 of the odds, well, one of them's gone, so there's only 4 odds left now out of the 7 to choose from. So again, odd, then even, then odd is 5/9 times 4/8 times 4/7. So that's the second scenario done. If you notice, actually, these numbers are the same, so it's the same calculation again, essentially. Third scenario, what about the chance of picking even first? Well, 5/9 of the cards are odd, therefore the chance of picking an even first would be 4 out of 9. Then there's still 5 odds left to pick from. If one's been picked first, there's 8 cards in total, so picking odd second, if even comes first, the chance of that is 5/8. And then odd again, if odd was picked the second time, there's 1 fewer odds left, so 4 odd cards, now out of a total of 7 cards left. So this third scenario is 4/9 times 5/8 times 4/7. And lastly, the chance of being even, then even, then even, probability of picking an even first is 4/9. So if an even's been picked first, there's then going to be 3 evens out of 8 to choose from for the second picking. Then for the third picking, there'll only be 2 evens left out of a total of 7. So even, 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 the probability of that is 4/9 times 3/8 times 2/7. So what we need to do now is just to actually calculate this horrible beast here. But I'm going to just give you a suggestion. What you might want to notice is the first 3 here, the numerators in different orders are 4, 4 and 5 for each, and the bottom numbers are 9, 8 and 7. So we'll just do the first one and then multiply it by 3. So a simple way of doing this might well be to do the following. So I'm going to do 3 lots of, in brackets, 5/9 times, just be careful you're typing it in, 4/8 times 4/7, because these 3 first brackets are all the same value, just different orders sometimes. Then finally, because this final one is different for the evens, I need to add on to that, in brackets, 4/9 multiplied by 3/8 multiplied by 2/7. Press equals and cross your fingers. We end up with a probability of 11/21, and that is our final step. So the final probability of the sum being an even number for these 3 pickings is 11/21. The last question, which is never straightforward. L is a straight line with equation y equals 2x minus 5, and C is a graph with equation y squared equals 6x squared minus 25x minus 8. Using algebra, find the coordinates of the points of intersection of L and C. You must show all your working. Well, first of all, we need these to match. So that's y and that's y squared. So my first step here, I'm going to change this one from being y equals to being y squared equals. We can then compare like for like. So if this is y, y squared will be 2x minus 5 all squared. So let's expand out these brackets. So using the grid method, 2x multiplied by 2x is 4x squared. 2x multiplied by minus 5 is minus 10x. Same here again. Then minus 5 multiplied by minus 5 comes out as positive 25. Simplifying all this, we're going to have 4x squared minus a total of 20x plus 25. Now we've got y squared in one of these equations and y squared in the other. Where the straight line and graph intersect is when the y values are the same, therefore the y squared values need to be the same. So in other words, it's going to be when the 6x squared minus 25x minus 8 is the same as 4x squared minus 20x plus 25. So that's what we've got here. So we can now rearrange and try to solve. So what I'm going to do first of all, I'm going to subtract 4x squared from both sides. That gives me 2x squared minus 25x minus 8 equals minus 20x plus 25. To solve a quadratic, it's best to have it all on one side, all equaling 0. So that's what I'm just going to try to do. I can get rid of this minus 20x by adding 20x to both sides. That will then give me, on the left, 2x squared minus 25x plus 20x gives minus 5x's overall. Still minus 8 gives 25. Then to get it all equal to 0, if I take that 25 from both sides, and therefore now need to solve when 2x squared minus 5x minus 33 equals 0. At this step now you can either use a quadratic formula, but this actually does factorise. So I'm in a factorising mood, so I'm going to show you how to do this using factorisation. So the way I do it, in terms of factorising a quadratic where the coefficient of the squared term is non-zero, I'm going to forget the 2 for a moment, just multiply it by the minus 33 at the end. So I'm going to think of it as being x squared minus 5x minus 66. We'll come back to where the 2 vanished in a moment. So factorising this as a simpler one, I need to find two numbers that multiply together to give minus 66, but when I add these numbers together, it gives me minus 5. With a bit of thinking, hopefully you can see that 6 and minus 11 work. So I'm going to put x plus 6, x minus 11 equals 0 like so. But at this stage, like I did say, we'll come back to this too. And what we now do is we try to divide the 6 and the minus 11, both numbers in the brackets, by the 2. So I'm just going to put both these values over 2, and then if we can simplify the fractions we do, or if we can just divide exactly, even better, and we do it. So 6 divided by 2 we can do, that becomes x plus 3. 11 over 2 neither simplifies nor divides, so for this one we just simply shove the 2 in front of the x instead. So then get 2x minus 11 equals 0. That's now fully factorised. You could have actually left it like this if you wanted to, but anyway, this is a more versatile way which always works. So what two values of x would make this expression equal to 0? Well, clearly we've got to have either x equals minus 3, or if this bracket's equal to 0, that would be the case when x is 11 over 2, which is 5.5 as a decimal. But we want the coordinates where they intersect, so I need the x value and the y value. So when x is minus 3, what's y going to be? And similar for this one. We need to remember the formula for what y is. Y is 2x minus 5. So if I just write this down the side, we can use this to generate the value of y. So when x is minus 3, the corresponding value of y will be 2 times minus 3 minus another 5. 2 times minus 3 is minus 6, minus another 5 gives minus 11. So when x is minus 3, y would be minus 11. Or when x is 5.5, y is going to be 2 times 5.5 minus 5. 2 times 5.5 is 11, then 11 minus 5 gives 6. So I've now got my coordinate pairs. So one pair is minus 3 and minus 11, and the second pair of solutions is x is 5.5 and y is 6. So writing this as coordinates, which is what the question asks us to do, the coordinates of intersection are, from the first one, minus 3, minus 11, and from the second one, which I've highlighted in green, it could be 5.5 and 6. So that's all we need to do for that question, and because it's the last question, that's all we need to do for the entire paper. Quite a slog, I know, but I hope you found some of that useful. If you have, please do comment and subscribe, and let me know in class if there's any questions you want me to go through in any more depth. I'm sure there's lots, because these GCSE maths papers now are probably harder than they've been for a long, long time, at least 20 years or so, in my humble opinion. Like I said, thanks so much for listening. I'll hopefully see you in class soon, or virtually if you leave a comment and subscribe. But thank you very much, and do take care.